Hi, and welcome to the solution of the buying pizza exercise, where we are going to dive into quadratic equations, function definitions in Python, and method fsolve. As always, fully commented notebook is linked in the description of the video. The task was the following. Imagine you want to go for a pizza with your friend. Menu is quite clear, smaller pizza costs 100 money, and bigger one which has a diameter larger by 10 centimeters costs 200. Which means that two smaller pizzas cost exactly the same as one bigger one. First question is, at which diameter D it pays off to buy two smaller pizzas rather than one bigger one. In the second part of the exercise, we would like to exclude 1 centimeter of the dry edge of the pizza because we don't care about it, because we don't eat it. So how is the solution going to change then? I have already opened the notebook with the task which is to be filled, and which is also linked in the video description if you would like to fill it by yourself. Typical modules, as in the introductory notebook, are already imported here: numerical Python, NumPy as NP, and matplotlib pyplot for plotting graphs as plt. One advanced feature, which is not essential for our problem at hand, but for your information, rcparams enables me to set parameters for all the plots in the notebook at once, so globally. Back to the task, we are supposed to compare areas of pizzas. So imagine a function of area, which clearly depends on the diameter of the pizza. And that is therefore our independent variable. Your first task was to create the reasonable values for this pizza diameter d. So let's call it d, and we will linearly space the values, so functional in space. Diameters are clearly positive, so let's start from 0, go to 50, and create 101 values. In order to show the values, we can use print function, so print d. Run the cell and we see the array which goes from 0 to 50. Here we have mathematically expressed the condition we are solving for. We are comparing areas of two smaller pizzas with one bigger one. We assume that the pizzas are circular, therefore their areas are expressed as area of circle, and after rearranging both terms on one side, we solve for the condition when the whole expression is positive. Of course, it would be possible to create two functions and compare those, but we are going to rearrange and create just one function. For the functional values, we therefore rewrite the expression we have above. So we write 2 times. In Python, pi is written nppi, and we multiply by the d over 2, and all this squared, 2 asterisks. After rearrangement, we have change of sign, and now we have just one pizza, so just nppi times the same term, but we have now diameter bigger by 10, so we need to put brackets d plus 10, and all the diameter is divided by 2, and again squared. We run the cell. For plotting, we use plt module and function plot, so plt plot, which takes our independent variable x-axis, which is d, and our function, which was f. And we are supposed to plot also the x-axis, which is the same module, and its h-line, horizontal line, ax h-line, which goes through 0. We define the color black, and we make the line with thinner, which is, let's say, 0.5. Already by eye, we can see the intercept with the x-axis, and therefore from approximately 23 or 25 centimeters of the diameter, it will always pay off to buy two smaller pizzas because the areas are always bigger. Now let's calculate the intercepts precisely. We have at least 2 options. In the quadratic function introductory notebook, we have a method in case we know constants ABC, which are the parameters of general expression for quadratic function. But for that we would need to rearrange our expression on paper first. It's not always practical because expressions can get complicated, and Python has a function, fsolve in that case. Fsolve solves equations numerically, which is using certain algorithm in loop and progressively approaching the correct solution. Before using fsolve, we need to import it from scientific Python package module optimize. We run the cell, and as an input, fsolve needs another Pythonic function, which we are going to define by command def. Now think about mathematical function. It has a name, in our case area diff, and it takes independent variable as an input, which is our diameter. Then it does some operations, and after that returns some functional values, which here I called variable diff. So diff has a meaning of area difference between the two pizzas minus 1. And this is what we are supposed to fill in here. So actually, this is exactly what we have already defined as f above. So we repeat the expression as before, np pi times, now we have d over 2 squared, and now we subtract the area of the bigger pizza, np times, now again d plus 10, and all this divided by 2 and squared. Now we are going to test our function, so we write area diff, and as an input it takes the diameter, in this case 10. It returns minus 157, which means that for diameter of 10, area of two smaller pizzas is smaller than one larger one by 157 centimeters squared. So we want our values to be positive, so we are in the negative side. We can try to increase our diameter, so we are slowly approaching 0. Let's put 20. Now we are minus 70, 24, very close to 0, and 25 is going to be already positive. So our solution is somewhere between 24 and 25. Now is the time to try fsolve method. I told you before that our newly defined function area diff can be used as an input for fsolve, which is done right here. I have fsolve and input argument is function area diff. When I run the cell, Python returns an error. What does this error mean? fsolve tells us that one required argument x0 is missing, and this x0 serves the purpose of first estimate of a solution. Also, if you write fsolve and hit Shift Tab, function documentation should appear, which can help you with what parameters are required and what the functions do. Also note that the error message is printed in a way that Python tries to help us how to fix our input. So let's do it according to what he tells us. fsolve, we put area diff as before, and now we add one argument, which is x0, and we equal it to 15. And now fsolve runs and returns actually a number 24.14, which you remember that the solution should be between 24 and 25, so it returns a correct solution. fsolve is a mighty instrument, however we cannot blindly trust it. You can think of it in the following terms. Since fsolve needs from us the initial estimate for the solution x0, it means that the resulting output might depend on the value of it, and we are going to demonstrate it here. You know that quadratic function can have two intercepts with the x-axis. So if we are with our estimate too close to the first root, let's say I put x0 equals to 1, then I am getting the other root as a solution, which doesn't make sense for our exercise because negative pizza diameter is illogical. If we are very close to the bottom of the parabola, we will get actually iteration error or warning because the fsolve will be confused. It's at the bottom of the parabola, and if he goes left or right, actually he cannot distinguish which way is better, so it will get stuck. And when we are close to our desired root, we will always get the right solution even if we start from very high values. So you should be always aware of this catch, and the best way to avoid any problems is to have some kind of idea of how your function looks like and what is the reasonable solution you expect. This is the end of the first part of the solution. In the next video, we are going to extend our solution in order to disregard the dry edge of the pizza. See you there!